The ground beneath your feet is not still. It never was. But right now, in this moment, seismologists across 3 continents are staring at the same data, cross-referencing the same fault lines, and arriving at the same conclusion. A conclusion so alarming that several have quietly stopped giving interviews. The Cascadia Subduction Zone stretches 700 miles along the Pacific coast, from Northern California all the way up through Oregon, Washington, and into British Columbia. It is one of the most powerful fault systems on the planet, and it has not produced a major rupture since January 26, 1700, the night the entire Pacific Northwest coastline dropped by 6 feet in under 4 minutes and sent a tsunami racing across the ocean to Japan. That was 325 years ago. The average recurrence interval for a full Cascadia rupture, what scientists technically classify as a magnitude 9.0 or greater, is every 200 to 530 years. Do that math. We are already inside the window. In fact, depending on which geological model you trust, we passed the midpoint of that window decades ago. But here is the detail that stops seismologists cold. It is not just Cascadia. The Hayward Fault runs directly beneath the East Bay communities of Oakland and Berkeley in California. It ruptured in 1868. The average recurrence interval is between 140 and 170 years. Last year, that clock hit 157 years. The United States Geological Survey rates the probability of a magnitude 6.7 or greater on the Hayward Fault within the next 30 years at 33%. Higher than any other fault in the Bay Area. 33% does not sound terrifying until you realize that is roughly the same odds as rolling a 1 or 2 on a standard die. And you are rolling that die every single morning. Then there is the New Madrid seismic zone, buried beneath Missouri, Arkansas, Tennessee, and Kentucky. In the winter of 1811 and 1812, it produced 3 earthquakes so powerful they rang church bells in Boston, reversed the flow of the Mississippi River, and were felt across more than 1 million square miles. The central United States has no retrofitted buildings, no early warning systems, no evacuation culture, no memory of what happened the last time New Madrid woke up. 3 fault systems, 3 overdue clocks, all ticking simultaneously. Here is what makes this moment different from every other earthquake warning you have heard before. Scientists are not speculating about whether these quakes will happen. That debate ended years ago. The geological record is unambiguous. These faults will rupture. The only variable left, the only one, is timing. And timing, for the first time in history, is something scientists are beginning to close in on. New GPS monitoring networks installed along the Cascadia margin have detected something that was not visible 5 years ago. The locked zone, the section of fault where the 2 tectonic plates are stuck together, building stress like a compressed spring, has expanded. It is wider than previous models predicted. That means when it releases more energy across a larger area. The compressed spring is bigger than anyone thought. And the people living above that spring number in the millions. Seattle, Portland, Eugene, Tacoma, Victoria, combined population over 5 million. All of them sitting inside the zone seismologists call the damage corridor, the stretch of coastline where, when Cascadia finally releases, ground shaking will reach intensity 9 on the modified Mercalli scale. That is the level where well-built structures suffer severe damage, where poorly built structures do not survive at all. FEMA has already run the projections. The numbers are not classified. They are sitting in a public report that almost nobody has read. In a full Cascadia rupture, FEMA estimates 13,000 deaths in the immediate event, over 27,000 injuries, 1 million people displaced from their homes. And that is before the tsunami. The wave generated by a magnitude 9.0 Cascadia rupture would reach some coastal communities in 15 minutes. 15 minutes. That is not enough time to drive to high ground. In many locations, it is barely enough time to run. The town of Seaside, Oregon sits at sea level 3 miles from the coast, on a flat plain with 1 road out. population 6,000. When researchers modeled a full Cascadia event, they estimated that most of Seaside would be submerged under 30 feet of water within 20 minutes of the rupture. The mayor knows this, the city council knows this, the residents know this, and every single morning, people wake up, make coffee, and drive their children to school on that one road out, because what else do you do with information that has no resolution date? That question is the psychological core of everything that makes the Cascadia threat different from a hurricane, a wildfire, or a flood. Those disasters come with warnings. They develop over days or hours. You can watch them approach on radar. You can pack your car. You can choose when to leave. An earthquake gives you nothing. No warning, no countdown, no radar signature, just silence. And then the world moves. But here is where the science has shifted in a way that almost no mainstream outlet has covered. For decades, the assumption was that large subduction zone earthquakes were essentially unpredictable at any time scale shorter than centuries. That assumption is cracking. Researchers at the Pacific Northwest Seismic Network have identified what they call episodic tremor and slip, slow-motion earthquakes that occur deep beneath the locked zone, invisible to human senses, detectable only by the most sensitive instruments ever built. These slow slip events repeat on a remarkably consistent cycle, roughly every 14 months along the Cascadia margin. The last major slow slip event ended 7 months ago. That means the next one is approaching. And while slow slip events do not cause the rupture directly, they redistribute stress along the fault in ways that scientists are still working to fully understand. What they do know is this: the relationship between slow slip cycles and major rupture risk is not random. It is patterned, and right now, the pattern is in an active phase. This is no longer a conversation about geology. It is a conversation about probability, and probability, unlike geology, operates on human timescales. The USGS has a number they publish but rarely emphasize. The probability of a magnitude 8.0 or greater Cascadia event within the next 50 years, between 10 and 15%. That sounds manageable, but a magnitude 8.0 is not the scenario that keeps seismologists awake. The scenario that does is a full margin rupture, magnitude 9.0 or greater, which carries a separate probability estimate of approximately 10 to 15% within the same 50-year window, 1 in 10. Within our lifetimes, for the largest earthquake the continental United States has ever experienced, and the infrastructure sitting above that fault has not been retrofitted to survive it. Oregon alone has over 1,000 school buildings that have never been seismically retrofitted, children sitting in classrooms built in the 1960s, above a fault that geologists describe as the most dangerous in North America. Washington State has identified over 1,100 unreinforced masonry buildings in Seattle alone, brick structures that perform catastrophically in major seismic events. The retrofitting program exists. The funding does not. This is the part of the story that never makes the headline. Not the geology, not the fault maps, not even the death projections. The part that should terrify every person living in the Pacific Northwest is the gap between what we know and what we have done about it. That gap has been growing for 30 years while committees met, budgets were debated, and the fault kept loading. Scientists have a term for the period immediately before a major rupture. They call it the interseismic phase, the long, quiet interval where stress accumulates invisibly beneath the surface, where nothing appears wrong, where every calm morning feels like evidence that the danger has passed. The Cascadia Subduction Zone has been in its interseismic phase for 325 years. Interseismic phases end. They do not end gradually. They do not send warnings. They end in seconds, with a rupture that travels the full length of the fault at the speed of sound, releasing energy equivalent to thousands of nuclear weapons, shaking the ground continuously for 4 to 6 minutes, while every unreinforced building, every unanchored bridge, every unretrofitted school above it tries to absorb forces it was never designed to survive. The scientists who study Cascadia do not argue about whether this will happen. They argue about what we are still willing to do before it does. And right now, the answer to that question is not enough. The clock has been running for 325 years. It does not stop because we are not watching.